Today we will go over our domain and range notes. The domain is a set of all possible x values and input values. It's written from left to right or least to greatest. The range is a set of all possible y values or output values written from bottom to top, which is also least to greatest. Then we have continuous data. Continuous data is a set of data that can take any value within a finite or infinite interval, and it's written using inequality notation. Discrete data is a set of data with distinct and separate values, and it can be counted. It's written using curly brackets. When we're given a graph, on our graph we can have an open dot or a closed dot, or open circle or closed circle. An open circle means that we're using the inequalities less than and greater than. A closed circle means we're using the inequalities less than or equal to or greater than or equal to, because the closed dot means included and the open dot means not included. So if we have a value that is included, then we can use the less than or equal to. Equal to means that that number is included in our domain or in our range. We also can have an open circle or a dotted line for our graph, or a solid line. So if we're given a solid line, that is the same as a closed circle, and we'll use the inequalities less than or equal to or greater than or equal to. And then for a dotted line or an open circle, we use the inequalities less than or greater than. All right, now we're going to get into some examples of different representations showing discrete functions. We'll start with ordered pairs. Ordered pairs is just a list of points. So in this ordered pair example, we have our x values are -2, 0, 2, and 3. And we're going to write those values down here where it says ordered pair in the domain and range section. Remember, for the domain, you have to look at the x-axis. And for the range, you have to look at the y-axis. Domain is a set of all possible x values, and the range is a set of all possible y values. So in the ordered pair, our x values are -2, 0, 2, and 3. And remember, we have to write those from least to greatest. And then our y values are 8, 5, -4, and -1. Again, we're going to write those in order from least to greatest. So our y values, or our range, is -4, -1, 5, and 8. Now for the mapping diagram. For the mapping diagram, remember, we have the left side and the right side is our x and our y. So this left side is our x and the right side is the y. All right, so we have x on the left, y on the right. We're going to write down our x values in order from least to greatest. That's going to be our domain. So our domain for the mapping diagram is -4, -1, 0, and 3. Remember, write that from least to greatest and close it off with curly brackets. So our y values from least to greatest are 2, 7, 11, and 14. All right, let's go to the graph. For the graph, we have distinct points, which is exactly what a discrete function is. It just gives you specific points. So we're going to look at each of the points and determine what our x values are first for the domain, and then we're going to look at the y values to determine the range. So our all right, so for the points, we have 0, 1, 2, 3, and 4 for our x values. We're going to write that for the domain. Remember, write it from least to greatest in curly brackets. And then we're going to do the same thing, but now we're looking at the y-axis for the range. So right here we have 0, 0, sorry. This is 0, 5, so our y value is 5. We have 10, 15, 20, and 25. So in curly brackets, we have 5, 10, 15, 20, and 25. Close it off with curly brackets. Now we'll do the last representation, which is a table. For the table, we have our x values and our y values. Our x values are 1, 2, 3, and 4. We're going to write those in the domain section in order from least to greatest, 1, 2, 3, 4. And then our range is the y values. Also written from least to greatest, we have 3.5, 7, 10.5, and 14. All right, now for the example question, it says Samantha is going to a pumpkin patch and is going to pick up 1 to 3 pumpkins. The function s of x equals 15x plus 12 represents the total cost, s of x, that it costs based on the number of pumpkins x picked. Fill out the table for this function and help determine the domain and range. So we're going to determine how much money Samantha is spending if she buys 1 to 3 pumpkins. Our independent variable here is the number of pumpkins, and our independent variable is our x. That's our input. So we have to put how many pumpkins she's going to buy in order to get the cost. So our x values should be 1, 2, and 3 because she can buy either 1 pumpkin, 2 pumpkins, or 3 pumpkins. And then we're going to find the total cost that she has to spend if she buys 1 pumpkin by plugging in our x values. I'm going to write over here off to the side. You don't have that space on yours, so maybe write on the bottom. But over here on the side, I'm going to write, well, if I want to buy 1 pumpkin, my function becomes s of 1 instead of s of x. So here's my function. S of x equals 15x plus 12. Now, I'm going to find how much it would cost to buy 1 pumpkin. So my function becomes s of 1 equals 15 times 1 plus 12. 15 times 1 is 15, plus 12 is 27. So to buy 1 pumpkin, it'll cost her $27. Now to buy 2 pumpkins, I'm going to replace x with 2, so my function becomes s of 2 equals 15 times 2 plus 12. 15 times 2 is 30, plus 12 is 42. To buy 2 pumpkins, it'll cost her $42. And then lastly, to buy 3 pumpkins, I'm going to plug in 3 for x. My equation becomes s of 3 equals 15 times 3 plus 12 15 times 3 is 45 plus 12. 45 plus 12 is 57. So to buy 3 pumpkins, it'll cost her $57. Now I'm going to plug in those values for my domain and range. Remember, domain is the X values, so my domain is going to be in curly brackets 1, 2, and 3, because that's all the pumpkins she's going to buy. And my range is going to be those Y values right here for S of X. So 27, 42, 57. Another way you could have solved this is once you get the amount of money for your first pumpkin, which is $27, you can just add $15 each time to get how much the pumpkin will cost, how much the pumpkins will cost in total. On the left side, we're going to find the domain and range for that graph. As you can see, this function is linear. For domain, we're going to be looking at the X values. So we're looking at the X axis. So we're looking at these numbers right here. We're looking at these numbers. So I'm going to look from left to right. My leftmost value for my function is -2. My rightmost value is +3. When you write domain or range using inequality notation, you're going to start with your variable. So since we are looking at domain, our variable is X. We're going to put X in the middle. And then we have our inequalities. If you have 2 dots, this dot and this dot, so you have 2 ends, you have a starting point and an end point. You have 2, this dot and this dot. If you have those 2 dots, you're going to write your inequality with both less than symbols. So your symbol should always face that way, less than. And then you're going to put your numbers. So my left number is -2, and my right number is 3. Now I'm going to make sure that I'm using the correct inequality symbol. So if you remember, for a solid dot, you're going to use less than or equal to or greater than or equal to. And for an open dot, you're going to use less than and greater than. Since on -2, we have this solid dot, we're going to use less than or equal to. And for the number 3 on our x-axis, we have this open dot. So we're going to leave it as less than. Now for the range. For the range, we're looking at the y values. So now we're going to be looking at the y-axis. So now we're looking at the y-axis right here. We're looking at these values. We're going to see from what number to what number does my function span across. When you write the range for functions, you're going to write it from bottom to top. So my lowest number is -4, and my highest number is 2. If it helps to draw the lines like I'm doing, you should do that as well. So for the range, since we looked at the y-axis and our y values, we're going to put y in the middle. And then we have our inequalities. We have our inequalities facing this way, less than, always. When you have 2 dots, you will have 2 inequalities. 2 dots on your graph, 2 inequalities when you're writing the domain and range. So our bottom number for the range is -4, and our top number, or our highest number, is +2. Now on our low number, -4, we have an open dot. So we're going to leave this symbol alone. We're going to leave that symbol how it is, because an open dot means I can have less than. But for the value 2, my high value, I have a closed dot, which means I'm going to use less than or equal to. So on my inequality, I'll write less than or equal to. Okay, for the next graph on the right side, we have a quadratic function. This quadratic function has arrows here and here. Anytime you see two arrows, that means that your domain is all real numbers. Anytime you see two arrows on any function, your domain is going to be all real numbers. So since we have two arrows on this quadratic function, down here I'm going to write all real numbers. You can also write all real numbers as this R with the line next to it is kind of connected. So it's a symbol R. Or you can write it as negative infinity to positive infinity with parentheses. I've even seen it written as negative infinity, inequality symbol, to positive infinity. I've seen it written all of those 4 ways, so make sure you write all of those ways on your paper. Now, our range is our y values. So if you look at your function, we look at the range from bottom to top. So our lowest number, or our bottom number, is 1. And our function goes up. Since our starting value is 1 and our function is going up, then I'm writing my range as y values greater than or equal to 1. Y values greater than or equal to 1. If my quadratic was going down, like this, then I would write y values less than or equal to 1. All right, now we have an equation. I'm not going to graph this equation, but you should graph this in Desmos. Once you graph that in Desmos, you'll see a line. Actually, I think it goes this way because that's a negative slope. Your line should go like that. And in Desmos, there are no endpoints. So you don't have a dot right here and a dot right here. It actually continues forever in both directions. So since this line continues forever left and forever right, that means our domain, which is our x values, is going to be all real numbers. And our function also continues forever up and forever down. So since I see two arrows and they're going forever in the left direction and forever in the right direction, I have my domain as all real numbers. And since my function is also going forever up and forever down, that means my range is also all real numbers. And remember, you can write all real numbers multiple ways. I'm just writing it this way. You can even write it with the R with the bracket, or you can do negative infinity to infinity. You can write it like that. All right, and the last one, this graph is an exponential function. So since I have two arrows mean that my domain is all real numbers, always. Anytime you see two arrows, you should think, oh, my domain is all real numbers. All right, but my range is a little tricky. So if you guys remember the horizontal asymptote, our horizontal asymptote is where our function, so remember, this line is my function. This function will approach my horizontal asymptote, but it'll never cross it or touch it. That's the number that I need to use for my range. So let's write a little note right here. Use the horizontal asymptote for range. And remember, you only have a horizontal asymptote for exponentials. You don't have a horizontal asymptote for quadratics or linear. Only exponential functions have a horizontal asymptote. So in this case, my horizontal asymptote is 3 because my function is approaching 3, but it doesn't ever cross it. So that means my range is going to be, of course, a y value. I'm looking at my y values. So what y values does my exponential function span across? Well, it's going to start at 3 and go up. And up is greater than. So my range is y values greater than 3. The reason why my inequality is not greater than or equal to is because this function right here does not touch 3. It doesn't cross, like, okay, let me show you. If I had a graph, say my function actually looked like this. You see how my blue line passed y equals 3? It doesn't have to touch on the y-axis, but this red line right here, this is all y equals 3. This whole thing is y equals 3. So when my blue line doesn't actually cross it and it keeps on leveling out and it'll just ride right there, that's a horizontal asymptote. And that's what number I'm going to use for my range. If my function just so happened, instead of stopping right above 3 and leveling out, if it just so happened to come down like this, then 3 would no longer be my horizontal asymptote, because now right here I have a point, and that point is like negative 1 point, let's call it 1.8 comma 3. So there is a value on my function that has 3. So just be careful of your horizontal asymptote. A lot of students think that it has to cross the y-intercept. A horizontal asymptote has nothing to do with the y-intercept. All right, is that it? That's it for your notes. Make sure you glue those down in your interactive notebook, and you should have an assignment after this or before this in Carnegie.